Now this is a little bit more complicated. This will be better for your older students. But this talks about being able to light up 2 light bulbs. And there's a couple of ways that you could try to do that. And the first way, kind of the first way you would think of, would be just to make one giant loop with 2 light bulbs in it. And so we're going to try that. Here we have our wires. And we're going to connect them. There we go. Could you please hold this for me? Go ahead and connect those wires there. Thank you. We're going to connect the wires here, and there we go. Now, this should work because you have a completely connected circuit moving along wires, and you have your source here. And if your source were strong enough, this would work. However, what's happening is that you're seeing as the electrons pass through this light bulb, they've got enough energy in them to make that light bulb light up. But by the time the electrons have gone through this wire and lit this light bulb and gone through this wire, they just don't have enough energy left in them to light this light bulb. And this type of a circuit we call a series circuit. They're just lined up in a row, they're lined up in a series. And this doesn't work quite as well for lighting your 2 light bulbs. It makes sense, and it's a good thing to try, but you just don't have quite enough energy coming from that power source to make that light bulb light up. Is there a way to make that light bulb light up with this power source? Well, actually, there is. By creating what we call a parallel circuit. And so we're going to go ahead and connect these. There we go, thank you, my assistant here. Whoop. All right, so we've got them all connected. Now this is connected in parallel. I'm going to go ahead and tighten that a little bit. There we go. All right, go ahead and hold that. You can actually put your hands right on it, right there. Again, not enough energy here to zap you or hurt you. Now, this is in parallel. Now, why did it work this time or it didn't work before? And here's the reasoning. You have your electrons flowing from your source down this wire. And when they come to this point right here, well, now they have a choice. They can go through this light bulb, or they can go down this wire and through this light bulb. And so now you have your electrons splitting. And some go this way and some go this way. The ones that go this way, they light this light bulb. It travels back through here. The ones that come this way light this light bulb. So now the electrons that have gotten to here have not lit another light bulb, have not lost their energy already on another light bulb. They simply took a different path, and they still had their energy at the point that they came across this light bulb. Compared to your series circuit, where they went right from one to the other. Here we show again. Again, we have the one lighting up and the other not. So that explains our series and our parallel circuits. Now we come to our last task here. We have first some definitions. Once again, conductor and insulator, as we talked about before, kind of just redefining those. And then letting you experiment with it by trying different materials and seeing which is a good conductor and which is a good insulator. So we're going to go ahead and connect right here. And these wires can be a bit tricky to work with. It helps to kind of wrap them really tightly there sometimes. Okay. So here we go back to our simple closed circuit is a good place to start. All right, now we're going to try different materials to see if they conduct or allow electrons to flow or if they don't. So this is a paper clip that allows those electrons to flow very easily through them. That's a good conductor. And the next page talks about trying a few different types of materials. Here we go. can try a paper clip, or a paper clip we've tried. We can try cotton ball, not a very good conductor. It's actually an insulator. A rubber band. You can try your own finger. Humans aren't very good conductors. A piece of foil works really well also. So that completes the tasks in this little flip book. But we also have some fun ones over here. I'm going to have our student help us figure this out. So student, using what you've learned about electricity, I have connected some of these numbers on the back. And I want you to try to figure out which numbers are connected and which numbers are not. And when you think you've got a connection, go ahead and draw it on your paper here. And then we'll turn it over and we'll see if you were right. Okay? Think you got a connection? All right, go ahead and draw it. Alright, so you got a couple of connections there, huh? Alright, so this is a good methodical way to go through it, going through each number one at a time. And for sake of time, 2 to 7, okay. All right. Did you see that one? Mm-hmm. Okay. So now they can check their work by flipping it over and seeing how they did. So you can see here, it'll be backwards. We can flip it upside down maybe to check. Just leave it the way it was. So this was 4 to 8, and you can see that was correct. 4 to 8 were connected. And here we have, now this is interesting, there's more than one right way to do this with the information she was given. We saw that there was a connection between 1 and 2 and 1 and 7, and she drew a line between each of those, and then another line between 2 and 7, but you can see it was actually connected. 1 and 2 were not connected to each other, they were connected through 7. So this is a really good teaching opportunity to explain there are multiple ways that we could have connected these. And with the information given, there are different correct answers. So you can do it that way to show that there are different ways that would still be correct. The other thing you can do is write on the side and say, use only 2 wires. And then you would realize, okay, that uses too many wires. So there has to be just 1 wire connecting the both of them. So it depends on how difficult or how complicated you want to make it. And we have one more activity over here. This is discovering the secret word. So you need to crack the code by finding out what letter goes with the number 4. So check your letters. Hey, you got it. There's another 4. Well, that looks quick. And can you guess the last one?
T.
There you go. All right, so our secret word was circuit. And you'll notice now on this one, we couldn't really help but cross some wires. So in order to keep you from getting multiple things lighting up, we insulated those wires with some electrical tape. On this one, we were able to simply avoid wires crossing, but here we used some tape. And that shows, again, how you complete a circuit and how you can use the wires and with your knowledge of circuits and electricity to find out your secret word. Thank you for joining us for Spectacular Science Electricity.